I'm going to be helping you understand how to disassemble, reassemble, and repair this unit, primarily calibrate this unit. So the purpose is to really familiarize you to be able to repair this unit along with the service manual. Can everybody who's on the line, can everybody hear me well? Maybe say hi.
Yeah, I'm good, thanks.
Okay. Well, welcome. The format for this is going to be a 30-minute repair presentation, approximately. And we would ask that you would hold questions to the end. We will be taking questions, but hold them to the end. And also, as we're going through the presentation, please mute your phones so that we can run through the presentation. This will be uploaded to DMX. It is being recorded, and we want to have a clean presentation, so please mute those phones. So I will be going through 4 different product lines today. I want to apologize in advance. I'll be going through this introducing myself, introducing the unit on each of them. So there will be a little bit of repeated information, but this will allow us to upload each video to DMX as its own entity. So why would you need to calibrate this unit? Well, primarily what we're looking at, there is a troubleshooting guide in your service manual. And again, I would point you back to that service manual. But primarily what we're looking at is any speed issues with this unit. We do have heating units and stirring units in this product line. So we have hot plate stirrers, hot plates, and stirrers. Today, we'll primarily be looking at the most difficult part of the calibration, which is the calibrating the stir function on this unit. The heating function is very self-explanatory, and again, you can go back to your service manual to find to deal with that if needed. But really, what we're looking at for stir calibration is if the unit doesn't reach the desired speed, so either it's going too fast or too slow, that would be one reason why it would be returned to you for calibration. So next, we'll look at some safety precautions. Go to your service manual for full safety precautions. But primarily what we're looking at is, number 1, only connect this to a specified power source that's properly rated for the unit, whether it's a 120 volt or a 230 volt unit, the correct frequency. So 230 volt units, we're looking at, both we're looking at 50 to 60 hertz. And it has to be a grounded electrical outlet. These units were made for a laboratory environment. So as you're repairing them, you want to simulate those conditions. You can see here we have a sturdy workbench, sturdy table. It's clean, it's dry, it's not humid, climate-controlled environment. The other thing we're looking at is we will be using a ESD strap. Anytime you work on electronics, you do want to use ESD protection. So if you're working with the circuit boards or any of the electronics in these units, make sure you're grounded. This can be very difficult if there's ESD damage to a board. It can be very difficult to find out what's going on in the field. So always be grounded during the repair. So you can see here we have a fluid As I said, I'm not going to be going through heating units today, heating calibration today, but if you are working with a heating unit, make sure you're using an appropriate fluid. Today we have water, and for the stir calibration, we're using water, but water can boil away. There are certain silicone oils that can be used. Big consideration, if you do use a higher temperature oil, is to make sure that there is no moisture in it. If you're using if you're heating at very high temperatures, the moisture can boil before the oil does and cause a popping in the mixture. So make sure you're using the appropriate fluid for the temperature that you're working with. All right, next we're going to look at the tools and equipment. So I'm going to zoom in here on our lab bench. And what we have, again, for calibration, we have a 250 milliliter beaker with a stir bar. There's a magnetic stir bar, the stir bar that comes with the unit. And that's filled with 100 milliliters of water for the calibration. We have a spectral trim pot tool. Get that in there so you can see that. This is going to help you adjust the speed of the unit. We have a variety of screwdrivers, Phillips head. I have a pair of small pliers, very useful for this. We have a phototachometer. And we have a piece of foam for setting the unit on once it's open. For testing, you're also going to need, for heating units, a temperature probe and a high pot insulation tester. So going in and starting to familiarize you with the unit. This is both a heating and stirring unit. It's a hot plate stirrer. So all the way counterclockwise is off, and you turn up the stir function with the right knob between 1 and 10. This is not necessarily meant to be a linear scale. So 5 is not necessarily always half speed. It is a rheostat, and there can be some differences between knobs. But 1 is low, 10 is high, and there is an off position for the stir. You can hear that click. The heater is on the other side, and again, you turn it up to heat and down for off. We are going to leave that completely off through this training. There's also a power switch on the back. I'm going to unplug this and show you this. So heating units have this power switch on the back. The 0 is off and the I is on. We're going to leave it on for this training. Stirring units don't necessarily have this hard on-off, but it's there for safety for the heating units. As you turn this up, doesn't necessarily, if you set it to a very low speed, sometimes it needs to overcome friction. So I'll set this on here to let you see it. Sometimes it needs to overcome motor friction before turning on. So if you set it to 1, sometimes it doesn't start right away until you turn it up a little bit, get it started, and then you can move it down to the desired speed. This unit right now is not calibrated, so we will be going through that calibration for you. Okay. I'll turn it off. We'll unplug it. Anytime you're working on a unit, anytime you have it open, as you're working on it, as you're disassembling it, make sure it's disconnected from power. All right. This unit is extremely easy to open. It just has 4 screws here on the bottom. There is a little difference between 120 volt and 230 volt. The 230 volt also has a filter, and that's removed by removing these 2 screws once you get the base off. I'll show you that. As I'm working on the unit, it's a good practice to always use safety glasses as well. And of course, use that ESD wrist strap that we talked about. So I'm going to remove the 4 screws. And we will remove the base of the unit. Keep these screws, they will be needed for reassembly. So as we open it up, you can see the filter inside right here. Hopefully that clarifies as you go on. And we're going to disassemble that as well. This filter does have 2 nuts on the other side of it. So a pair of pliers can be very useful to hold those nuts as you undo those screws. And again, save them for future use. If everyone would please just mute your phones, because we are recording this, and this will be used into the future. All right. The base plate can be taken off and set aside along with the screws. And here we have the inside of the unit. What you want to make sure at this point, just do a check of everything on the unit. Make sure that the wire routing is going down the side of the unit. None of the wiring is damaged, and that the wiring is out of the way of the motor. Okay. Next, we can take our foam pad and set the unit on it. And we're going to look over the entire unit and make sure that there are no scratches, no dents, no chipping paint. no aesthetic issues that the customer can might complain about. In fact, on any of these units, as you initially, when you initially get them, it's always good practice to look them over, to record any issues that you see with the housing, with the general look of the unit. Pictures are also a good thing to have every time you repair a unit. All right, so next we're going to get into the calibration. Here's where the trim pot tool comes in and the tachometer. You'll notice I have this stand here that raises up the unit. That's really so I can get underneath very easily. This unit is easiest to repair, easiest to calibrate when it's at shoulder height. For calibration, I'm going to take the unit, and right there, if you can see, yes, it's clarifying. You have a rheostat, a trim pot, and you insert the trim pot tool, flat end of the trim pot tool, right into that rheostat. Turning that one direction increases the speed. Turning it the opposite direction decreases the speed. We're going to plug in the unit to the proper voltage source. Make sure the unit is on, which I did earlier. I'm going to put the sample on top, the stir bar. Now the stir bar will center to the magnet on the unit. Then we're going to turn this on. Now, as I said before, it might need to be turned up a bit to overcome the friction of the motor, and then once it gets started, it can be turned right down to 1. Now this knob can go below 1, it can go above 1. We want to calibrate it when it's right at 1. What we're looking to do is turn the trim pot until at 1, that stir bar is barely moving. So turn it down. And it's a very touchy calibration to do. Very, very small movements affect the stir speed quite a bit. So you want to do it in very small increments. If everyone could mute their phone on the other end right now so that we have a clean presentation without excess noise on the other end, that would be terrific. So we're continuing to adjust this in small increments. And I'm just turning the trim pot. If it stops, I'm turning it back up. Normally when I turn the trim pot back up, it overshoots and goes too fast. And then I slowly adjust it back down to the right speed. It's just barely turning. There, it stopped again. Turn it up a bit. It's a little bit fast. Back down. Still a little fast. And when we get it very slow, so that we can either use a tachometer right here on the stir bar. Now, as that stir bar spins, the tachometer is getting 2 pulses. So you have to cut what the tachometer says in half. But what we're looking for is for the unit to be 250 RPM, between 50 and 250 RPM. So we're cutting that 399 in half. So that's about 200 RPM. It's a little bit fast for this. We can also go off the underneath, off the shaft. It's about the same. I'm gonna try to get this just a little bit slower, even though it's within range. I think I could get it a little bit better. Here, it stopped. I'm turning it back up. There we go. That's perfect. On this unit, the slower you can get it, the better. But what we want it to be doing is turning without turning off. All right, so we've done the calibration at 1. I'm just going to adjust this unit so it's on the foam a little better. So it's turning slowly at 1. Next, we're going to turn the speed up to 5 and make sure it increases in speed. If the unit doesn't increase in speed, there's probably something more important than just a calibration going on, and that's when you would contact us, and we would either walk you through a more intensive program or replace the unit. But here it did pick up speed. We're looking good there. Then we're going to increase the speed to 10 and take a reading on this. And what we want, again, the tachometer gets 2 pulses, so whatever you read on the tachometer, you're going to cut it in half. So that's right around, it's fluctuating a little bit, which you would expect, but it's right around 1,000 RPM. You want it to be under 1,500 RPM. So that's a good calibration here. You will repeat this test for after you get it closed up. But right now we're going to turn it back down to 5. Make sure it slows. Back down to 1. Make sure it doesn't stop. If it does stop, then you would have to recalibrate it again. But you want to turn it up 5 to 10. Make sure you have control. Back down to 5, back down to 1. Do that several times so that you can be sure that the unit is going at the proper speed. And not decoupling at high speed and going slow at low speed. One thing I didn't mention before, but I really should mention, is that this unit is fairly sensitive to voltage. So as you work with this unit, just make sure that you have it attached to a voltage generator that can give you a very precise voltage and frequency. All right, now we're going to put this back together. Take sample off. I'm going to unplug it. I'm turning off our voltage generator. Unplugging it. You're going to flip it over. Take the base plate. Take our screwdriver. And when you're reinstalling the base plate, the curved section and the switch section obviously goes towards the back. 4 to 30 volt units, you'll need to reinstall the filter. As you're doing this, refer to your service manual for the proper torques and Loctite specifications. Each of these units, as I'm going through, have very specific torque settings on almost all the screws that we use. Also, as you're doing this, make sure that none of the wiring gets bent. Okay. One screw in, second screw. So the wiring connections are pretty important that they don't get bent. So you just put in the screw lightly at first, and then you torque it down to the proper amount specified in the service manual. Next, you're going to make sure all the wires are routed the way that it came out. On heating units where you have the switch goes into this slot at the back of the unit. You can see that here and down here. The wires are all routed around the outside of the unit. And then you carefully replace the bottom housing, making sure none of the wires get pinched, and making sure that the power switch is correctly seated in the slot here. You can push on the power switch to make sure that it doesn't move. And last, we have 4 plastite screws that go back in. And there you have your calibration. After all this is done, you're going to reinstall or repower it, and you'll go back through the test procedure to make sure that the calibration is indeed correct through both of or after reinstalling the bottom, after putting it back together. There are tests for both the hot plate function as well that we're not going through today. See your service manual for those. See your service manual also for the final testing and packing. All the units that we're going to be talking about today are going to need high pot testing before packing. Anytime you open or close one of these units, we're making sure that a high pot test is run on the unit. Okay. So in conclusion, we're here to help. You can contact our customer service. If you have any issues at all, our customer service or our customer happiness rep will put you in touch with the proper person to help you, whether that's me, whether that's one of the other engineers here, or whether that's a marketing representative. You'll be put in touch with somebody who really knows the product inside and out. We're here to help you and help make this product line a success. Are there any questions? All right. Well, if there's no questions, we're going to take about a 10-minute break.
Hello?
Yes. Hello?
Hey, good morning. This is Al, OHUB US.
Good morning.
Can you hear me?
Yes.
Hi, good morning. Just have a question regarding the RPM. I understand from position 1, you said 50 to 250 RPM.
Yes.
And are you supposed to now, at speed 10, verify the 1000 to 1500 RPM and not really care about the position 5? It follows where you set the bottom and the top, and in between should follow both, right?
Exactly. We do verify the top position when we're calibrating it. For the final check, it is simply at speed 10, we do not want it to decouple. We want it to stir without decoupling. The speed 5 is just a simple check to make sure that it's not a simple switch on and off. So we want it to have some speed control in between. So it's just a visual check. It's not a check that we're going to be doing with the phototachometer or strobe.
Okay. And I guess the between 1000 to 1500 RPM, isn't that kind of like a big range? Or
it is. This is a rather inexpensive unit that it's kind of an industry standard to have that range. We have done tests against our competition, and we do beat our competition.
Okay. All righty. Well, and maybe just one last note that maybe we need to print out the RPM, the speed at 10 somewhere in the service manual. It wasn't mentioned anywhere, so maybe it's just me, but maybe that would help in the settings.
Okay. I'll look into that.
Yeah, thanks.
Thank you. All right.
Hi, Andy.
Hello,
Yes.
this is Andy.
No,
The guy on the video is Nate Nathaniel.
I think she's talking to the other
Oh,
Andy there.
sorry.
I'm sorry.
It's Corinne here
Hi, Corinne.
from Australia.
Hello.
Hi. Just a quick question.
Mm-hmm.
Just wondering, how much does the voltage fluctuate in the US?
That's a good question. Hold on 1 minute.
It fluctuates around 5%. That's a standard. I've seen it go a little lower, but it would depend on the facility, the time of the day, what equipment is being used in that same power line. But I would say from 110 to 120 is a pretty good, that 10-volt difference.
Okay, so I believe that may be what we're experiencing in
Go for it.
Australia, maybe. Because we have voltage from 230 to 250 can fluctuate by 20 volts
Okay.
in different locations.
Gotcha.
Yeah, for our Australian units, we are calibrating at 240 just to be on the safe side.
So if you do get,
So would you think, sorry.
yeah, no problem. If you do get a unit back, you can ask the customer to tell you exactly what voltage their specific line is rated at or is running on average, and calibrate to that. I do understand that can fluctuate, but you can get the calibration a little bit more accurate if you use the customer specified voltage rating.
Okay, I'll try that in the future.
All right. Any other questions? All right, so we're going to take a 10-minute break and come back and show you another unit. Thank you.